All right, so we're going to create a WebSocket server using Express. Let's start with npm init in your fresh new directory called WebSockets. Let's create an Express app. So we're going to npm install
the npm Express?
Okay, so we have Express installed. Now, the way that I start with creating a node-based WebSocket app is I Google for Express WebSocket. And instead of using Socket.io, which is no longer supported, we use something called WebSockets. What you'll find is a library called WS. And this is what it looks like. It's WebSockets/WS. So you'll find this page. On here, there is a Express example. So we're actually going to go through this and make sure that you have a working WebSocket example. Okay. So you have this in your notes. There's a lot of information here if you want to understand more of it. One important thing we got to do is npm install save WS. So that's the package name is WS. Okay, so let's install that now. Shoop. Okay, we got WebSockets and I want to create a WebSocket server. There we are. I also want to do it with Express. So I'm going to look at the Express.js example. We could really copy paste all this. So I'm going to give you a little bit of time to find this documentation. GitHub, WebSockets, WS library. Scroll down to Express.js example and copy this whole code snippet. Okay. And open up in your favorite editor, index.js. So I'm looking at our dependencies. We did install Express. HTTP is built in. URL is built in. And WebSockets WS is installed. We create an Express app. I'm going to add a port. So const port is process.env port default to 3000. Okay, so remember that. There's some middleware here. I'm not sure if I'm going to keep all this. Maybe I will, maybe I won't. What this does is respond to every HTTP request and just send back a message of hello. Right? So it doesn't matter what the URL is, it will send this back. Okay. Here's the juicy bits. Server. We create an HTTP server here, and we pass in our Express app into this server. Right? So we created a server here. And then WSS, this is WebSocket server. We initialize a new WebSocket server, passing in the server that we've created, right? So this is shorthand for server is server. So it's an option, passing in the server that we've created. More juicy bits. These are connection handlers. So when we have a WebSocket connection, then this callback function is invoked, right? So here we're just grabbing the location of what URL was accessed. Whenever we receive a message, then we're just going to console log that message. So this WS send will be sent one time right when a connection is created. So I will say connection to WSS has been created. Whereas this function will happen every time. Okay. Finally, it says server listen. So the server, the HTTP server that we created, will listen on port. So make that change from 8080 to port. Okay. Let's run this and see what happens with nodemon period. Should default to port 3000. It's listening. And how do we know if it's working? If we go into our browser, then go to localhost colon 3000. Colon 3000. Right? We get the JSON response back, hello. So that's the default behavior that I explained up here. Right? So app.use, we could still use Express, do app.get, etc. Right? That still works. That's all HTTP land. WebSockets is a different protocol. So we're not able to use our browser's URL bar to access the WebSocket endpoint. So, like I said, we can access the Express endpoints, right? Anything that we have here, hello, here, right? World, right? So anything, that's all Express, that's all HTTP. There is a site called WebSocket Echo, I forgot what it was. Here. If you just Google a WebSocket Echo, you'll get this echo test. And the site looks like this. I want you to be familiar with how it looks. It says websocket.org, and it's an echo test. By default, it's connecting to this location, which is the websocket.org's echo server. I could connect, and it says I'm connected. Then I can send messages to that server. Open my inspector in Chrome. Very important. You go to network, filter in WebSockets only, and then establish a connection. When I click on this in Chrome, we can see this tab called frames. All right, so these are the frames that are being passed between this open socket connection. I hit send, and it says received. So this is green is what I sent from the browser. This is the response back from the server. All right, that's just what's happening now. I can send multiple and other pieces of information. Okay. And you'll see that in my frames here. So it's a way to debug what messages are being passed from the browser to the server and from the server back to the browser, which is white. Now, I'm going to change this location. First, I'm going to disconnect. And I'm going to uncheck TLS, so it's going to be an unencrypted WebSocket connection. And then I'm going to change this to localhost colon 3000. When I hit connect, we're going to see if our WebSocket server is working, if it's listening for WebSocket incoming connections. So I'm going to hit connect. Here's a new connection here. And see this white? This came from the server. Right when we connected, it says connection to WSS, the WebSocket server, has been created. And it says that in the box here. Connection to WSS has been created. And so I can send messages, hello world, and it says sent hello world. So I sent it back. And if you see the handler on message, what's it doing? All it's going to do is console log received. So let's see if that console log appears. Yes, it does. It says received hello world. I'm going to do it again. Say, what's up, Jody? Send that. And I see that here. What you might be seeing, if you click on this, right, and you don't see anything at all, you just see that. The thing is, you don't have enough screen space. So you're going to want to full screen your whole Chrome browser and then bring this down. See that? That's weird. Right? Isn't that crazy? But you do want to see both, because if I click on this, it'll give me the entire message. This is just kind of the heading of the message. This is the entire message. Yeah. So if I send a really long message, send it to the server, I could click it and get the whole message. Okay, cool. So this proves that we have a working socket server. Also, this proves it. Now let's make it useful. Let's make a chat app or something. I want to add Express static middleware. How do I do that? Use. App.use. Express.static. And then we'll do /public. Okay? Got that? App.use express static public. Let's create that subdirectory. Public. In there, we'll create index.html. Index.html. Okay, so the steps was include the Express static middleware. Point it to public. And then create the public subdirectory. Create the index.html. in your Sublime Text editor, open up index.html, do an HTML5 boilerplate. We'll call this WebSocket chat. Okay. We will have a script file. So that's going to be in scripts app.js. Okay, so I included one script file, scripts app.js. That needs to exist, so I'm going to create that in public. Scripts subdirectory, and in there we have an app.js. Okay, so this is what our HTML looks like so far. So for a chat client, we need a form to send data, and we need another form to display chat logs. So let's do that. How do we do that? Let's do a div with, I guess all we need is input. Yeah. Oops. Let's call this username. The placeholder of username. We'll have a message with placeholder of message, and we'll have a button. That says send. This button needs an ID. We'll say send button. Okay, this is our form for chat, our chat form.
Hey John, can you please start this code?
Yep. All right, so I'm going to create a div to contain the message log. So I'll call it message log. All right, it's going to be empty at first. So this is our index.html. I'm going to get rid of this app.use middleware here so that we can see this. There we go. OK. So what I did was I removed the default middleware route handler, and so we can rely on our express static middleware. And when you go to localhost :3000, you should see this form. So our job here in app.js is to establish a WebSocket connection to our WebSocket server, and then listen for send button. Listen for send button click events to send messages to the WebSocket server. Finally, our last goal is to display broadcasted messages from WebSocket server. So we're going to do just this. Okay. So I'm going to start with an iffy. Okay. And then I have to establish a WebSocket connection. So where I start is by Googling for the native JavaScript WebSocket implementation. So I'm not relying on a library here. So it's on MDN. Let's check its availability. Why does it look different? Oh my God.
They changed the.
All right. Is it better? Let's see.
I don't like it. But
All right. So this is what I meant by check the availability. It says this is an experimental technology. So check the compatibility guide. This might not work on versions of Internet Explorer or Opera or Safari. So just check that. And if you did need it to, then you could use probably a polyfill or a library to do that. For now, most modern browsers will support this. So this is the API documentation. I'm looking for a guide or an example. Hey, look at that, an example. I'm going to copy the example. Okay, so I create a new WebSocket to localhost :3000. So here's our event listener for open. We could say hello to the server, fine. I also want to append to the chat log. I want to say you are connected to the server. It's good feedback. So I'm going to add a const for the send button is document.getElementById send button, and the chat log, is that what I called it? Message log? Message log. Message log is going to be message log. Okay, so I have 2 elements. I'm actually going to need the other elements too, so username and message. So if a connection is opened, this is how you send data from the client to the server. You say socket.send. Socket is the instance of the WebSocket connection. I'm also going to append to the message log. And how should I append this? Huh? I guess I want to go a little bit elegant, maybe. So I'll make this message log a UL. How about that? And then it's just a bunch of li messages. So I'll say like append to log connected to chat server. All right, so I'm going to abstract away the append to log function. Put it right here, I guess. No. Append to log function with a message, and this says new message is going to be document.createElement. We'll create an li element. New message.inner text is going to be the message. And then we'll append to message log. So message log dot append child new message. Okay, so that's what append to log does. It creates a new DOM element, sets the inner text. Connected to chat server. Sweet. Okay. This is what we have so far. We have connected to chat server, right? And then here, listen for messages. So this is the client side saying that when the server sends us a message, the client, then do this. Event is your event object. On the event object, we have data. The other things you could do with the event object are defined here. So all the things that you might want to do. Really though, I don't use anything other than just get the data. So not only do we want a console log message from server, actually I don't want to do that. I want to append to log. So I'm going to change this to append to log and just the event.data. So we can see what the server is sending back to us. So let's do this and let's, connection to WS has been created. John, and send a message. Yeah, I didn't make this functionality work yet. We hit send, nothing happens. I want this to send a message to the server through here. Okay, let's do that now. I need to create a event handler for send button. How do you do it? Is it add event listener on click E, right? So when we click the send button, we'll take we have the name. We'll send a message first. So to send a message, it's going to be socket.send message. So this is raw. This is like super raw. Also, this probably has to go up here, right? All our const at the top. Send button, like that.
But you can open it. So
Okay, refresh, send a message,
Then you can
and I see message hello. All right, so when we click, we send the message to the server. Now it's the server's job. I'm going back to the server code. It's the server's job to broadcast that message. So there's a lot of ways you can organize this structure. I'm going to create a simple array, not the best structure. I'll say users is an array, right? When someone connects, then I'm going to say users dot push ws, right? It's very similar to the socket server you created with Node. Wait, that's on connection. Here, on connection, there, users push. When we receive a message, we're going to broadcast to all the other users. So users dot for each. I keep forgetting if it has a capital E. Okay. User. And each user is an instance of a WS, a WebSocket connection. So I could say user dot send that message. Okay, you guys got that? Right now it's sending to every user, including yourself, so it's not super great. Once we have this broadcast working, so hit, hey, cool. So everyone else, you can actually go, no, I have to change my code. If you're gonna connect to me, I have to change my code to access the WebSocket connection here, so. Okay, this works. Now, you can go to 10.019:3000. Okay, I'll send this out in Slack. Please be nice on my server. Hey, look at that. So now send a message. Send. Do you see my messages onto your screen too? Is that what's happening? Okay, so let's make this more useful. That's our goal. I don't know who's saying what. Well, I kind of know who said that. Though, if you put a name in here, like Hitler, I shouldn't say that on video. John. Okay. I see send, right? I don't see John there. So let's figure out how to do that. When I send a message, how I really use WebSockets is I don't send just plain text. I send JSON objects. And I don't just send JSON objects. I have codes for what that JSON object is. Because if you saw in the debugging, there's no information about the message. So I like to give my server and my client information about the message. What that looks like is when I send a message, I'm going to create, so I'm going to say json.stringify an object. And these objects are special. I make them up. I'm making them up right now. So I make up something called op. Op is like a message. All right. So what I'm sending to the server is op as in operation. This operation is a message, so that the server knows what to do with this message. So it's like a chat message, right? Chat message. I should probably say chat. Chat. And then I have some other arbitrary values like what the message is. Message is this. Okay. So my protocol, I'm making this up right now, and I do this for all of my games. My protocol is every message sent from the client to the server or the server to the client has at least op. So what else is there? Socket send hello server. See this socket send hello server? I would do a json.stringify of an op of connected. That's it. I don't need any other information. I'm just telling the server I connected. Cool, so these are the two messages sent from the client to the server. Now I'm going to go back to the server and refactor all of the messages being sent. For example, this says user.send message. This is going to be JSON.stringify op, and let's do well, I call it chat, so that the client knows what to do with this piece of information. The message is going to be message, right? So I could just omit that. So why would I want to have op? Why do I have op? Why does that matter? Because when I receive a message, again, I don't know what to do with it. I can do a switch on message dot. I'm going to change this to payload now because message is a different meaning. So I'm going to say payload. So payload as in the payload that came back from the client. So I'll switch on the payload op. If the payload op is chat, then we're going to broadcast that. Then I can move this code down here. Okay, I'll break. Illegal break statement. Why? Oh, I missed something. There. Okay. There's another one, case of connected. What do I do for there? Maybe I'll console log. A user has connected. Can you start to see how this could be useful now? Like more than just chat, we could do anything. We could change colors on the screen. We could order a pizza, and you could send a pizza to somebody because of these ops. So op chat, op connected, and other things. Do I have any other send? Send. So message is going to be payload dot message. So how do I know what's on the payload? Well, I'm defining my own interface. I say if there's a chat, I expect there to be a message on the payload, right? So you have to start thinking this way when you're designing your application. And for connected, I expect there to be nothing else in the payload. So this WSN connection to WSS has been created. This no longer fits my protocol. I'm sending a straight up string here. I don't want that. So I'm going to change it to use my protocol, as in send JSON.stringify of an op that says successful connection, whatever. I'm not going to do anything with it anyway. Successful connection. So that if the client or if somebody is working on my team and wants to do something when there's a successful connection, like make it green, put an alert, then they can listen for this message and react to that. That's it. I think that's all my sends. Send, send, send. So now all my sends back and forth are all this shape. They have op and they have an optional payload. Now, finally, when I append message, so where is that append? Here, event.data. Event.data is now the op object. So I'm gonna say const op is no payload is JSON.parse event data. So because I'm sending back only JSON stringified objects, I can confidently parse it out, knowing that it's going to be JSON formatted. So it's very critical to keep everything the same format. So once I parse it out, I could do the same thing. I could do a switch on the payload's op. If that payload has op of chat, then what should the client side do? At this point, the client can append to the log, right? So append the payload.message. There's other things that can happen that the server can send back, like successful connection. And I don't want to do anything for that. I'm just going to break. Oh, really good thing you should do is have a default case. So for an op that you don't expect, you could do a console.error received, or was it unsupported op, and then just print out that whole thing, which is the payload. It's a really good thing to do. So it helps you debug and be like, oh, I forgot to handle this op case. JSON stringify that payload, right? So message const payload is JSON dot string parse the incoming message. There, that will do it. Okay, there we go. Now it's working. So now we could send more information than just messages. So let's do that now. Here, when we send a message, where do we send a message? Socket send message. Here, I can add the username, which is the username.value. Does that make sense? Or is everyone completely lost? Like, basically, instead of sending dumb strings, we're sending a structure, right? So we're sending a structure back and forth so that we can do special things based on that structure. So if I'm sending back a username to the server on the chat op, then when we receive a message, we can expect a username on that payload. So when we append to log, I could say who sent that message, payload.username. Now we have confidence that username will be there because every time you send chat, there's a username and a message. Back to the server side, when we broadcast, we have to send both the username and the payload username. Right? So now it's a lot smarter, and we can do a lot more things with this. So append to log, finally, it takes in a username and a message. Then our inner text will be username and then message. All right, so we just made our chat application smarter, and this is definitely something you'd use in the real in a real application. Okay, so everyone, put your real name and give some greeting. Greetings. I don't know if it'll work. Well. Spoon is a spoon. There is no spoon. Ben is a robot. Is that Ben?
Is that Ben?
Okay, so if you can imagine how useful this is, imagine this case. Watch. Case move right, right? So this payload user and could have a payload, distance and move user. So you could tell every other connected client that you moved right in a game, for example. You see how your switch statement can get really big.
So on Move, do you get requests in games or something? Does it send something?
So if you're making a game and you said, press the right arrow and you go right, as you go right, you send a message to the server.
It's like a listener?
Yeah, it's like a listener that everyone's listening on.
Oh, I see. So then instead of move right sends something, and then is this do you make up this case name or something?
I made it up.
Okay. So
Yeah.
then you have to add some value to it.
Yeah, you do something based on
Add some context and move right.
Yeah, so death, and then you do something when you see the message called death. Then you do game over. And then game over might not have any payload at all. You just, when you receive death, you died.
I like this more now.
Right? So that's why we have op.
I see.
And this is our important switch statement that based on what happens here, you can do things on a server. You can kick people out of the room. You can send private messages. You can route messages to different rooms. Like you could have chat rooms. Like case, create room. Create room. And then you'll do something like rooms dot create room with a name, right? And where the name would be payload dot name. Payload dot room name. After I did that, I would have sent that user. So I would say ws.send and then json.stringify, and the whole thing, and say successfully created a room, right? So it looked like this. Create room success. And it doesn't need a payload. Okay. That's it. Let me show you a real use case then of how the ops work. Okay, let's look at an example. I'm gonna go to Dragons. Have you seen this one? Dragons.gomigames.com. Can someone go to dragons.gomigames.com, please? Whoa, he's shaking the UI. Stop shaking the UI. There you go. I'm gonna create a game. So a WebSocket connection has been created. See op create. Create code is ZZJ. So you're gonna go to that page and say ZZJ join. And you see how when you joined, it sent a message to my client. It says opponent joined. When I got opponent joined, then I have a ready button, and so do you, I think. So if I hit ready, then it says ready player one, and then ready player one. That sounds weird.
Oh, you can see his moves. Wait.
Yeah, don't look at the screen though. Just
The screen
Wait,
is-
don't look at what?
don't look at my
Look at the
screen.
What
fine.
screen?
Oh, don't look at his screen because you're gonna pick.
Yeah. Okay, so one thing I had to do when designing this was to make sure that if there was a hacker, they wouldn't see your choice prematurely. So I couldn't see your frame of what you chose. I'm gonna choose something. I think you chose scissors. Oh,
She definitely shows scissors. Don't worry about it.
all right. I'm gonna choose rock.
Okay.
Okay.
Yeah, sure. Oh.
Yeah, so look at that. So you see how these messages came back from the server. It says player one chose, player two chose, and then my UI can react to these messages from the server. So here's the resolve of who won. Let me show you this payload. It's pretty important to look at it. So op resolve, player one did rock, player two did scissors. The results are rock wins, and then what happens next?
And is that like your op file?
This is the one message that I sent through from the server to the client. Ready? You got it? All right, I'm gonna do this. Bam. Oh.
Yeah.
Right. So she chose. So see the green? That's what I send to the server. The server's sending a lot of data back to us so that we can stay in sync. I'm gonna do this. Bam.
Oh, that's the op.
Yeah.
Op resolve, payload.
Yeah.
Player one.
And she wins, and I'm about to die.
Op
All right. So
resolve.
I'm gonna heal. She's killing me. So I have 10% left.
I'm not cheating, I swear.
All right. I'm gonna heal. I'm gonna heal really hard.
Go hard.
I'm gonna heal very hard. Hey, look at that.
Oh.
All right. I think that's enough to visualize like how WebSockets work. You can do more than just chat. We're not even chatting with each other. I'm destroying Liz right now. Look at that.
Okay.
Uh-uh.
You can just look.
Oh.
He's taunting you. Scissors.
Nah, wait.
No, I'm telling you.
Come on, Liz. I want to see the last. I want to see the last thing, the last message. So, Liz, can you pick rock, please?
So this one?
It's gonna destroy you. Oh, what? I meant pick paper. Can you pick paper? Maybe. Maybe not. That was weak.
I'm
This is a
still
demo.
alive.
Just
Barely.
a demo.
What do you want me to choose?
Paper.
5% health.
All right. So you should be dead.
0 health. And,
Payload.
what happened?
And then it says game over, and it shows the unicorns won, and you're smashed under a rock. So you see these UI UI updates are reactive to what comes back from the server. So the JavaScript can just do whatever I say it should do based on these
Those are
opcodes.
like switch cases.
Yep.
Player 2 choose. Resolve. Game over.
Yep. Like player 2 chose, so I know that the player 2 chose something. And then we update the UI based on that. And Victor is 1. Look at that.
Hey.
Cool. So that's WebSockets. Hope you learned something.